You step outside tonight and look up, expecting the familiar glow above the tree line. It isn't there. No crescent, no soft silver light spilling across the yard, nothing but a smear of stars where something enormous used to be. Your phone buzzes with a headline that sounds like a joke. The moon is gone. But the real answer is far stranger than any joke, because within hours, your entire world starts to unravel in ways you never expected. You probably think of the moon as decoration, a pretty light that occasionally reminds you to howl at it. Why would losing it matter? You still have the sun. You still have gravity holding your feet to the ground. Surely life just continues. It doesn't. The first thing you'd notice, if you happen to be standing on a beach, is the ocean pulling back and refusing to return the way it should. Tides on Earth are mostly a tug-of-war between the moon's gravity and the planet spinning underneath it. Without the moon, the sun still pulls on the oceans, but its tidal effect is less than half as strong. Within a day, the twice-daily swings you grew up with shrink dramatically. Tide pools that once refreshed themselves every 12 hours now sit stagnant for far longer. Fish eggs laid to hatch precisely when high tide arrives never get their cue. Crabs that time their mating swarms to the lunar rhythm wander the sand in confusion, their internal clocks ticking toward an event that no longer happens. You might wonder if that's really such a big deal. It is, and marine biologists have been tracking exactly how big for decades. Researchers studying coral reefs on Australia's Great Barrier Reef, including the work led by Peter Harrison in the 1980s, documented something remarkable. Entire coral colonies release eggs and sperm into the water on the same night, synchronized almost to the hour, cued by moonlight and water temperature together. It's one of the largest reproductive events on the planet, and it depends on a light source you never thought twice about. Remove the moon, and that synchronization simply falls apart. No moonlight, no signal, no mass spawning. Coral reproduction doesn't stop entirely, but the precision that took millions of years to evolve collapses within a single missed cycle. Meanwhile, up on land, something even stranger is happening in the dark. You've probably never considered that a dung beetle might care whether the moon exists, but it does, intensely. In 2003, biologist Marie Daki and her colleagues discovered that African dung beetles navigate in a straight line at night by reading the polarized light pattern the moon casts across the sky, essentially using moonlight as a compass. Without it, the beetles Daki studied wandered in circles, unable to find their way. Multiply that confusion across every nocturnal creature that has quietly depended on lunar light for millions of years, moths calibrating their flight paths, owls timing their hunts to moonlit visibility, migratory birds using celestial cues, and you start to see cracks spreading through ecosystems that look, on the surface, completely unrelated to a rock orbiting overhead. And the sky itself would feel wrong in a way that's hard to describe until you experience it. Night would become genuinely, uncomfortably dark. Not the soft darkness you're used to, broken up by a bright gibbous moon washing out the horizon, but a deep black punctured only by starlight. You'd actually see more stars, ironically, since moonlight usually competes with faint ones for your attention. But that beauty comes at a cost, because your own body runs on cycles shaped by exactly this kind of light. Some sleep researchers have found subtle links between lunar phases and human sleep patterns, though the science here remains genuinely uncertain, and the effect, if real, is small. What isn't uncertain is that thousands of other species evolved far more sensitive relationships to that light, and losing it overnight leaves no time to adapt. Here's where the story gets stranger still, because tides and dung beetles are only the surface. The real catastrophe is happening slowly, invisibly, deep inside the planet's spin. Your Earth doesn't just orbit the sun. It wobbles, tilts, and rotates on an axis that gives you seasons. That axial tilt, currently sitting at about 23.5 degrees, isn't naturally stable. In 1993, astronomer Jacques Lascar and his colleague ran long-term simulations of the solar system and discovered something unsettling. Without a large moon nearby, a planet's axial tilt can swing chaotically over millions of years, sometimes tipping nearly on its side. The moon acts like a gyroscope's steadying hand, its gravity locking Earth's tilt into a narrow, predictable range. Remove that hand, and over the coming millennia, your planet's tilt would begin to drift unpredictably. Winters could become summers in ways no calendar could ever forecast again. Ice sheets could form at the equator while the poles turn temperate, all driven not by any single storm or eruption, but by a slow loss of gravitational balance nobody notices happening until it's already reshaping continents. You'd feel some of this faster than you'd expect too. Earth's rotation itself would speed up slightly, since the moon has spent billions of years acting as a subtle brake, slowing your planet down through tidal friction. Days would very gradually shorten. It sounds almost pleasant, an extra few minutes here and there, until you realize that every biological rhythm on the planet, including your own circadian clock, evolved around a 24-hour day locked in place, partly because of the moon's steady pull. Change that pace slowly enough, and life adapts. Change it because a stabilizing anchor vanished overnight, and you're asking billions of organisms to recalibrate systems they never had to question before. There's a quieter loss, too. One that has nothing to do with tides or ecosystems or wobbling axes. For your entire existence as a species, the moon has been a fixed point in the human imagination. Ancient calendars were built around its phases. Farmers timed planting by it. Sailors navigated by it. Poets wrote entire careers chasing its reflection on water. Every culture that ever looked skyward built stories around that pale disk, long before anyone understood tidal forces or orbital mechanics. Take it away, and you're not just losing a physical object. You're erasing a shared reference point that has quietly synchronized human storytelling across every continent and every era of history you can name. So maybe the moon was never just decoration after all. It was gravity, holding your oceans in rhythm. It was light, guiding beetles and moths and birds through the dark. It was balance, keeping your planet's tilt from drifting into chaos. And it was memory, etched into every calendar, every myth, every love song written under its glow. You step back outside tonight, and this time, the moon is exactly where it should be, hanging low over the tree line, spilling that same soft silver light across the yard it always has. It still looks like decoration, but now you know better. Somewhere in the dark, a beetle is finding its way home because of it, a coral reef is preparing for a night that only comes once a year, and your entire planet is quietly, invisibly, staying exactly where it's supposed to be.